Alright, this is my second question. So what would happen to the size of the centripetal force and acceleration if velocity was halved? So what we've got to establish is what the initial values were, and our initial velocity, if this is from the question on page 168, 6C, was 5.5. So we've run the calculations in part A of that question, and it worked out that the centripetal force was equal to 3 newtons. So those were the given values. Now what we're going to do is run the same scenario using our next value, which we'll call VF, which is the half. So half of 5.5 is going to be 2.75 ms minus 1. We're going to keep the other things the same. So mass is still going to be 0.1. Radius is still going to be 1 meter. And we're going to throw it into the equation, which is Fc is equal to mv squared over r. And we're going to see what effect that's had on the centripetal force. So our mass is 0.1, times it by 2.75, and then we're going to square that. Then we divide it by the radius, which is 1, and put that into the calculator. And this is the number we get out. Now, it might not be obvious to you, but that number there, if you times it by 4, it gives you what the original one was, which means by halving the velocity, you have quartered the centripetal force. So velocity halved, quarter the centripetal force is what we've worked out here. And the reason for that comes down to the fact that it gets squared. So because velocity is getting squared, it has a greater effect on the centripetal force than, say, if you just halved the mass. Alright, and the next part of this question, so it's not just asking you to comment on centripetal force, it's also acceleration. To find the effect on acceleration, we'll just use our same F is equal to ma formula holds true. And if our force has been quartered, so that one there has been reduced by a quarter, which is what we worked out up here, and mass had stayed the same, therefore acceleration will also have been quartered. So force and acceleration would have not.